And now, the exciting conclusion of inverse trigonometry. Yay! We have seen sine inverse, cosine inverse, and tangent inverse. We saw sine inverse. Its range is only quadrants -1 and +1. Cosine inverse's range is quadrant 1 and 2. And tangent inverse's range is quadrant -1 and +1. Of course, -1 is not a real thing. But for tangent, you can't include the y-axis because tangent is not defined there, so tangent inverse won't exist there. The point is, inverse trig is always going to be positive in one quadrant and negative in the other. And what we saw happen in the previous lessons was, if we were in a quadrant that the inverse trig didn't like, we moved to a quadrant that it did like, but still produced the same values. You should have been able to use those skills to start the homework and tackle questions like this, but here is the official lesson on these questions, and I am going to add a 7th example at the bottom of the page because it was a good example. Somebody asked a great question in period 1, and I want to make sure that it makes it into the lesson video. Well, luckily for you, we're going to learn them right now, right? So, lost no more. We're going to peel these things like an onion. Because they are not the same function and it's inverse, like this doesn't say sine inverse and sine, because they're not the same function, you are often going to need 2 images. It's almost a guarantee that you need 2 images. Especially if the trig inverse is on the outside. You'll notice these two have the trig inverse on the inside. Alrighty. Peel it like an onion, start on the inside. This says sine of 7 pi over 6. Which quadrant is 7 pi over 6? Quadrant 3? Yup. So I'm going to draw quadrant 3. Since it says over 6, what is the size of my reference angle in degrees, please? Someone shout it out. 30 degrees. Awesome. Thank you, Daniel. I think it's Daniel. Or is it Gavin? Oh, no, your guys' voices sound the same to me. Neither one of them is saying it was them. Okay. So it was Gavin? Gavin says it's not him. Definitely Allie. Nice deep voice. Should be a blues singer. Alrighty, well anyway, we're in quadrant 3, and in quadrant 3, x and y are both negative. We have a -1 across from our 30. That means we have a -√3 next to it, and a radius of 2. Sine is y over r. So sine of 7 pi over 6 is -1/2. You said what? You're confused already? I did sine here. Y over r. That's all I've done. Okay, great. So, because sine is y over r. I'm not doing inverse trig right now. I'm evaluating. What is sine of 7 pi over 6? Sine of 7 pi over 6 is -1/2. Here's what this question now says. Cosine inverse of, and I'll do it in blue because it came from this triangle, -1/2. So this is what we did. We evaluated this part.
Wait, so you used the sine?
I did sine of 7 pi over 6. No, I evaluated the inside first. Pretend all you saw was this. And I said, what does that equal? That equals -1/2. Which means the stuff on the inside of cosine inverse equals -1/2. So the question says, what is cosine inverse of -1/2? That's what it actually says. And now, because it's inverse trig, I get to ask you, where is the first quadrant where cosine would have been negative? Because that's what this says. Remember, all inverse trig results in an angle. This says there's an angle somewhere, and when I do cosine of that angle, I'm going to get -1/2. So what is the closest quadrant to home, meaning 0, where cosine is negative? Quadrant 2. So I'm going to draw quadrant 2 now. Cosine uses side lengths x over r. That means this is an x, this is an r in quadrant 2. Again, the x is -1/2 because the radius can't be negative. That forces the third side that we don't have to be a √3. So then what is the size of the reference angle in this triangle? It's a 60-degree reference angle. But it happens to be a 60-degree angle in quadrant 2. So what is that in radians? What is the 60-degree angle in quadrant 2? 2 pi over 3. Because it's across from the root 3. We know it's the 60 because remember there's always a 1 across from the 30. Hold on, this is two questions at once, ladies. Hold on. This is a 30, 60, 90 right triangle. And since I know it's x over r, I know that x is -1 because r can't be negative. And there's always a 60 across from a root 3. Okay? Now, the reason why we know it's 2 pi over 3 is because this is pi, which represents 3 pi over 3. So I am a third of a pi before 1 pi. So 2 pi over 3. Because 1 pi over 3, 2 pi over 3, 3 pi over 3. Okay? More comments, questions, criterias, what ifs, why didn't we's, anything like that? No? All right. So this is what your homework is actually like. Should be a lot of pictures on that homework. One of the questions on the homework has a bad answer. I'll correct it. Can we move on to the next one? Peel it like an onion. First thing we're going to do is we're going to figure out what is cosine of 0. Well, 0 is the positive x-axis. That's 0 radians and 0 degrees. So we put a coordinate there and we say if this is the unit circle, the coordinates there would be 1, 0 with a radius of 1. So what we're doing right now is we're evaluating the inside. Cosine is x over r. So what is cosine here? No, x over r. It's 1 over 1. 1 over 1. So the x over r gets us a 1. What this question actually says then is what is tangent inverse of the 1 that we just got? Remember, please, the result of all trig inverse is an angle. So we are hunting for a theta for which tangent at that theta would have given us the value of 1. Well, the input for all trig inverse is side ratios. That means that's supposed to be a fraction. So what is it as a fraction? 1 over 1. So in which quadrant would tangent have first been positive? Quadrant 1. So we've got our triangle in quadrant 1, and we know the y over x gets us 1 over 1. That means the radius is a root 2. And our theta goes right here. What is that as a reference angle? That is a 45-degree reference angle. So our answer is in quadrant 1, in radians, it's pi over 4. And there it is. Think of it as two separate questions. There's just one inside the other. But essentially it's two questions. Because you're evaluating standard trig, and then you're evaluating inverse trig for each question. Okay? Everybody all right with all that? Are we ready for the next one? Cool beans. Let's first evaluate the inside. Where is negative, and this was hard for period 1. Nobody got it right. Which quadrant would this land in? And you can tell me the coterminal quadrant. So where is negative 5 pi over 3? It's quadrant 1. Because this is almost negative 2 pi, isn't it? 6 over 3 is 2, right? This is almost negative 2 pi. If this is 0, it's also negative 2 pi. It's also positive 2 pi. You're right. Look. Think about it. One more third and it would have been negative 2, right? Okay. So that puts us in quadrant 1. Because this is clockwise, because it's negative. What is the size of the reference angle since it says over 3? 60-degree reference angle. Alrighty. We could fill out this triangle. There is always going to be a root 3 across from a 60. In quadrant 1, everything's positive. That makes this a 1 because it's across from the 30. Makes this a 2. Tangent is y over x. Root 3 over 1. I just evaluated the inside. The question actually says then, sine inverse of what the blue information gave me, root 3 over 1. And remember, the result of all trig inverse is an angle. So what this says is, find the angle where sine of that angle would have given us a y over r of root 3 over 1. And I'll wait for one of you. Find the angle where your y over r gets you root 3 over 1. Well, sine inverse can only give us back results in quadrant 1 and negative 1. Jared said it's undefined. Why? There it is. The radius cannot be smaller than the y value. The radius is supposed to be the largest side of a triangle. This is not possible. It's undefined. So this one's undefined because it described a triangle whose vertical leg is longer than its hypotenuse. Not possible. So we're always on the lookout for that. Cool? What about the next one? This? No, root 2 is bigger than 1. Think about it. 1 times 1 is 1, right? So root 2 is going to be, it's actually like 1.4-ish. 1.414, I think. Yeah, it's a little bit more than 1.4 because 1.4 squared is 1.96. So it's a little bit more than 1.4. It's 1.414-ish. It's irrational. So yeah, this, and so you might want to include in your notes why this was undefined. Because just writing undefined and barely understanding the material when you're in class means when you get home you have no clue why. Unless you rewatch the videos. It's because this describes a triangle whose vertical leg, the y length, is longer than the radius, the hypotenuse. Not possible. Alrighty. This is different from the ones we've done so far because this one, the inside is the inverse trig. The outside is standard trig. That tells me that my result this time will not be an angle. Notice that each of these resulted in an angle at the end. These two result in a ratio of side lengths at the end. Okay? So first things first, the inside. It says, there's an angle somewhere where sine of that angle gives me 1 over root 2. That's clearly positive. Which quadrant would that need to be in? What's the first quadrant where sine would have been positive? Quadrant 1. So I'm going to put that in quadrant 1. And the y over r for this is 1 over root 2. You know what the third side is, yes? It's a 1, right? Let me ask you a question. What if you didn't know the third side, but you knew these two? How could you have found the third side? Let's say it wasn't a special right triangle. Pythagorean theorem, a squared plus b squared equals c squared. This one just happens to be a special right triangle. but it didn't need to be. In fact, you might have noticed I have yet to write the angle on here because I actually don't care what the angle is. The question asks me to perform secant at this angle. This thing results in an angle. And even if I don't know the value of that angle, I can still tell you what secant is at that angle because the result of secant will be r over x since it's the reciprocal of cosine. What is r? Root 2 and x is 1. So the answer to this is root 2 over 1. And that was without ever writing what theta is. Because who cares? In fact, watch this junk happen. Who cares? It's not necessary. And to prove the point, I'm going to add example below this one that's not one of your two special right triangles to show you that you still have the ability to figure out the answer.
So what's the point of having the sine inverse on there?
The sine inverse, the point of it was that it gave you this triangle. That way you could actually perform secant in that triangle. Okay? Let me prove the point and make up a completely different example. And I'll do one where it's not one of our two special right triangles. Cool? All right. And what trig function do you want me to put on the outside? You got 6 options. Which one? Cosine? All right. Let's do cosine of, I don't know, feeling sine inverse? Okay. There. I just threw that one together. The inside of this says, there is an angle such that sine of that angle gets me negative 4 over 5. What would be the closest quadrant to home where sine would have been negative? Quadrant negative 1. Remember, in quadrant 2, sine is still positive. So sine inverse can only give you back angles from quadrant 1 and negative 1. That's its range, okay? So the one that's closest to home is quadrant negative 1. So I'll draw quadrant negative 1. The result of this interior would have been a theta. I don't know that theta, but I do know that I result in a theta. Yes? I know it's negative. I know that. Here's what else I know. The y is negative 4. The r is 5. What is the x? And you should know this x without doing any work. It's 3. This is a 3, 4, 5 right triangle, which is a very important triangle for the SAT math and ACT math. They show up on every SAT, ACT exam. 3, 4, 5 right triangles, okay? The interior gave me my theta, and I know it's negative. But other than the fact that it's negative, I don't know its value. Who cares? What is cosine at this theta? Well, cosine is x over r. And I happen to know both of those numbers. So it's not necessary that you actually know the theta that the inverse trig is creating. The inverse trig is creating a triangle for you to work with. And then the trig outside goes, okay, now that I have my triangle, let me do some evaluations.
So what's the difference between the being inverse and non-inverse?
You mean the order of the two?
No. You just said inverse and non.
So you mean the order of the two?
Yeah.
Like these first ones have inverse on the outside.
Yeah.
Okay, the result of all inverse trig is an angle. The result of standard trig is sides. So these, you produced some sides using the trig, and then used the sides to reproduce an angle. This used the sides to produce an angle, and then that angle, we produced more sides with it. Okay? So it's just the order in which we're finding material has been switched. When it's trig of trig inverse, you usually will only need one image. If it's inverse of standard trig, you usually need 2 images. That's not something I want you to memorize. It just ends up being a pattern that you'll eventually see. Even I don't memorize it. I just go, well, what am I going to need for this question? Do I need to draw something? Do I need to draw a second thing? Next, boop. The result of the interior will be a theta. It says, there is an angle such that tangent of that angle gets me 0. Well, tangent's y over x. How is it possible that y over x equals 0? Can't divide by 0. Y is 0. So if the top of a fraction is 0, the fraction's value is 0. The only way that tangent of an angle, y over x, gets you 0 is if y is 0. Where is y 0? The x-axis. This is tangent inverse, which only allows quadrants 1 and -1. So do I use the positive x-axis or negative x-axis? Positive. Somebody said positive. The one that's between quadrants 1 and -1. So tangent inverse has produced this coordinate. Cosecant is the reciprocal of sine. Sine is y over r, so the result of this question will be r over y. That means the result of this question is 1 over 0, which is undefined. You have now had 2 examples on this page that are undefined. But they're undefined for 2 completely different reasons. This one was undefined because it asked you to make an impossible triangle. This one is undefined because it asked you to divide by 0. Completely different reasons. Had this said secant of tangent inverse, we would have been fine. Because it would have been x, it would have been r over x. So if this had said secant of tangent inverse of 0, the answer would have been 1. If it had said sine of tangent inverse of 0, we'd have been fine, because it would have been y over r. We would have gotten 0 as our answer. It specifically is undefined because it asked you to divide by y, and y here is 0. So undefined for a different reason. Okay? A lot going on. A lot to absorb. And I told you I was only going to add 1 example, but I just realized that I'm actually going to do this one and add 1 more, just to make sure we have a fantastic, very full video, dense with knowledge. 5 pi over 4, which quadrant is that?
Bun cake day.
Ooh.
Teacher appreciation.
Okay, I don't know what I was saying before the bundt cake showed up for Teacher Appreciation Week. Oh, that's right. I was asking, what quadrant are we in? 5 pi over 4.
3.
Quadrant 3. All right. Quadrant 3. Psst, ladies. Shh. All right, since it says over 4, what is the size of my reference angle? 45 degrees. Good. Now I'm in quadrant 3 where everything is negative. That's a 45-degree angle. My side lengths then are -1, √2. Cosine is x over r. So what this actually says is sine inverse of, and my x over r is -1 over √2. Oh, wait. No, I'm not adding another example. It's just the end of this one. Okay, we're almost done. Losing my mind. Thinking about that cake. This says, what color do I want to use? Blue feels good. This says there is an angle such that sine of that angle gets me -1 over √2. But remember, inverse trig is lazy. So it says, what is the closest quadrant to home where sine would have been negative? Quadrant -1. Sine inverse and tangent inverse can only give us back 1 and -1 as quadrants. So I'm going to draw a quadrant -1, 1 and 2 for cosine. The reason why is because cosine is positive in quadrant 1 and negative in quadrant 2. Tangent and sine are these two. So y over r, oh, I forgot to draw my triangle. Oh no, I just drew on my shirt. The y is -1. The r is √2. That makes that a 1. What's the size of the reference angle then? Still 45. The only difference is it's quadrant -1, so it's a negative angle. The final answer is theta equals -pi/4 radians. Boom.
I have a question.
Yes, a question.
Why does for example, in the other sheet,
Okay, on the previous page,
like why does tangent like go across?
give me an example. Which one are you talking about? Example L? So it's not that tangent can go across. Here's what it is. The interior stuck me into quadrant 3, right? Okay, that's a problem. Because tangent inverse can only give us these two options. In quadrant 3, is tangent positive or negative?
Wait.
In quadrant 3, tangent is positive. So what quadrant is closest to home and tangent's still positive? Quadrant 1. So tangent inverse says
Negative x and negative
yes, because both x and y are negative. And you see, I didn't even fill out the triangle. I didn't need to because it had to be the same size reference angle. And the result was an angle. Now, do I know the side lengths of this triangle? I sure do, but they weren't necessary.
Then if it was on the top, then
When you say it was on the top, you mean if it was here?
it was constant too, then that's
Yes, in quadrant 2, tangent would have been negative, so tangent inverse would have said, well, quadrant -1's closer to home. And it would have brought it down here.
Can you go back to the next page?
Absolutely.
How can you just like tell like what like theta equals like
Right here, you mean? How did I know what theta was? Well, we knew the y and we knew the r, which means if you don't have your special right triangles memorized, you can do Pythagorean theorem to get this side. But these two side lengths are equal. That makes it isosceles. So it has to be a 45, 45, 90 triangle. It doesn't have a choice.
No, but like how do you just like look at that and like, oh, okay, so theta equals negative pi.
How did I do? Okay, so you know 45 is 1/4 of 180.
Oh.
Okay, so and I know it's negative because we said it's quadrant -1. That's why. Cool? These are all great questions sneaking in at the end of the video. Appreciate you, nerds.